section 5.4, our objective today is I can apply the definitions and identify the special properties of a rectangle, a rhombus, and a square. So let's start out with the definition of a rectangle. Okay, a rectangle is a quadrilateral with 4 right angles. Okay, and it is therefore a parallelogram, because if we have a quadrilateral and we have 4 right angles, then both pairs of opposite angles are congruent. Therefore, the rectangle is a parallelogram. So a rectangle is also a parallelogram. Then let's go on to a rhombus. Definition of a rhombus. Okay, well, a rhombus is a quadrilateral with 4 congruent sides. Okay, so a rhombus might be something like this, where all 4 sides are congruent, and therefore a rhombus is also a parallelogram because both pairs of opposite sides are congruent. Okay, and then the final definition is a square. A square is a quadrilateral with 4 right angles and 4 congruent sides. Okay? Therefore, a square is also a rectangle, and a square is also a rhombus. Okay? And a square is also a parallelogram, because if we have 4 right angles, opposite angles are congruent, and if we have 4 congruent sides, both pairs of opposite sides are congruent. Therefore, it must be a parallelogram. All right, now let's look at some theorems that apply to these special figures. Theorem number 1 has to do with rectangles, and it says the diagonals of a rectangle are congruent. Okay, so if we have some rectangle A, B, C, D, and I have diagonal DB and diagonal AC, then the theorem says that length of AC equals length of DB. In other words, segment AC is congruent to segment DB. Okay. The second theorem has to do with the diagonals of a rhombus, and it says the diagonals of a rhombus are perpendicular. Okay, so it says if I have rhombus A, B, C, D, and I have diagonal AC and BD, then I know that that is a right angle. Okay? And then the next theorem also has to do with a rhombus. And it says each diagonal of a rhombus bisects two angles of the rhombus. Okay, so in other words, if I have this rhombus and I have the diagonals, then if this is A, B, C, D, then this angle is bisected and this angle is bisected, and we know that those are all congruent to each other because opposite angles of a parallelogram are congruent. So if we bisect congruent angles, we get congruent angles. Okay, so therefore we have four congruent angles there. Okay, and then the next theorem actually comes from the idea of a rhombus, but it says the midpoint of the hypotenuse of a right triangle is equidistant from the three vertices. Okay, so what this is saying is we have some right triangle, okay, and it's saying that the midpoint of the hypotenuse, so if this is A, B, C, we'll say this is M, then this theorem says then that length of AM equals length of MC equals length of MB. So this segment is congruent to this segment, that segment. So the midpoint of the hypotenuse is equidistant from the three vertices. Okay, so in other words, we have three congruent segments. Okay, then the next theorem says if an angle of a parallelogram is a right angle, then the parallelogram is a rectangle. Okay, so here's what it's saying. We have some parallelogram, so we know that opposite sides are parallel. And we know that one of those angles is a right angle. Well, then we know that if we have parallel lines, then this angle and this angle have to be supplementary. So that has to be right angle. And we know that opposite angles of a parallelogram are congruent, so this has to be right angle and that has to be right angle. And so therefore, by definition, it must be a rectangle. Okay, and the last theorem says if two consecutive sides of a parallelogram are congruent, then the parallelogram is a rhombus. Okay, So again, we have some kind of parallelogram, so we know that opposite sides are parallel by definition of a parallelogram. And we know that this side and this side are congruent to each other. So this is congruent to this. Well, we know that opposite sides of a parallelogram are congruent, so therefore this side has to be the same as the green side, and this side has to be the same as the yellow side, and therefore all four sides are congruent. So by definition of a rhombus, those have to be congruent. Okay. All right, so let's summarize what we know about a rectangle. Okay. First of all, it has 4 right angles. Has all properties of a parallelogram and has congruent diagonals. And we know if one angle of a parallelogram is a right angle, then the parallelogram is a rectangle. Okay? So, example. Okay, so this is W, X, Y, and Z. And we have these diagonals that intersect at T. And this is a rectangle. So quad WXYZ is a rectangle. So that's our given. So if length of WY is 19, WY is a diagonal, then ZX is also a diagonal, and we know the diagonals are congruent, so then it must be 19. Number 2, if WY, length of WY is 19, then length of WT has to be what? Well, we know that the diagonals bisect each other, so therefore it has to be, WT has to be half of WY, so 19 divided by 2, or 9.5. Okay? If TX equals 4.5, then WY has to be what? Well, we know the diagonals are congruent. So TX and TZ are 4.5, which gives us 9. So XZ is 9. So that means YW or WY has to also be 9. Okay? If WY is equal to 3A plus 16 and ZX is equal to 5A minus 18, what is A? Okay, so WY and ZX are the diagonals, and we know that those are congruent. So if we just set them equal to each other, and solve for x, so subtract 5a from both sides, we get negative 2a plus 16 equals negative 18. Subtract 16, get negative 2a equals negative 34. Divide by negative 2, we get a equals 17. Okay? All right, so let's review what we know about a rhombus. Okay, this is a summary of what we know. It has 4 congruent sides, has all properties of a parallelogram. The diagonals are perpendicular, and diagonals bisect the angles they intersect. Okay, and we know that if 2 consecutive sides of a parallelogram are congruent, then the parallelogram must be a rhombus. So an example here is, this is A, B, C, D, and this is a rhombus, so we are told that this is a rhombus. So if AD equals 13, then AB also has to equal 13, because by definition a rhombus has 4 congruent sides. If measure of angle 4, well, let me number these. 1, 2, 3, 4, 5. If measure of angle 4 is 25 degrees, then measure of angle 5, okay, well, we know the diagonals bisect the angles that they intersect. Therefore, angle 4 and angle 5 must be congruent. So then angle 5 must be 25 degrees. Okay. If measure of angle DAB equals 130, so DAB would be this whole angle. If that equals 130, then measure of angle ADC okay. Well, if this is 130, and we know that these are parallel because a rhombus is also a parallelogram. So if this is 130, okay, then this angle has to be supplementary to this one, so this one has to be 50. So ADC would have to be 50. Oops. 50 degrees. Okay. All right, and let's move on to a square. So, summary of what we know about a square. First of all, has 4 right angles, and that's the key, and 4 congruent sides. Okay. Has all properties of a parallelogram. Diagonals are both congruent and perpendicular. And the diagonals bisect the angles they intersect. Okay, and so if this is a square, M, L, K, J, and this is X, this is 1, 2, 3, 4, 5, 6, 7, 8. If MJ equals 12, then ML has to be 12, and LK has to be 12. If MX equals 8, then XJ has to be 8. Okay? And measure of angle MJK has to be 90 degrees. Okay? Each of the numbered angles have measure of what? Okay, well, each of the numbered angles has measures of 45 degrees. Because if this is a right angle, then the diagonal bisects that right angle, so this is 45, 45. Okay, and the final one was the midpoint of the hypotenuse of a right triangle is equidistant from the 3 vertices. So if length of ST is 8, then length, oops, not ST, if length of XC equals 8, then length of BX has to equal 8. Okay? And if AX equals 12, then XC has to equal 12. Okay? So the idea that these are all equal segments. All right, that's it for today.